So, in order to understand matter, we need to understand their basic building blocks a little bit more. What the basic building blocks are called are atoms. So, there's three subatomic particles, and when you just think about words, sub, if you think about a submarine or something like that, that means below. So something sub, it means below. So a subatomic particle, I think of as like below the atom or inside the atom. So there's three subatomic particles inside the atom that help us understand matter just a little bit better. So the first one you see here is the proton. So proton, they use a lowercase p kind of as its symbol. And some of the elements have what we call a charge. Now, charge, when we think about charge, it's either going to be a positive charge or a negative charge. Okay, so when we talk about something having charge, it will either be positive or negative. So a proton has a +1 charge, and then a proton has a mass. Now, mass kind of tells us the amount of matter that's there. Now it's here where we define a new unit, and now the new unit, when I was studying it, we called it an AMU, see right here, which means atomic mass unit. The newer way is just to use the letter U. Okay, that's the new unit that they use for mass. Now, when we talk about mass, these particles are so small, I'm going to write a number up here. So 1 atomic mass unit is the same as 1.6726 times 10 to the negative 24 grams. Now you do not have to memorize that number. I don't have it memorized actually, but it's a negative 24. That means it would have a decimal place, 23 zeros, and then the 1. So this is a teeny tiny number. So when we talk, if we were talking about in grams, we would be working in negative exponents all the time. So instead, we have a unit that they use with these teeny tiny particles called the atomic mass unit, or U. Now, the proton has a +1 charge, an atomic mass of 1, and then it's located in the nucleus. Now, so if I were to sketch an atom, the nucleus is inside, it doesn't like when I try to make little circles. Okay, I'm going to change it, sorry. You don't need to hear this whole conversation I'm having with myself. So I'm going to draw, like here will be my nucleus. We're going to kind of draw it. And so the nucleus is a tight cluster of in the center of an atom. Now it does not have like a membrane around it or anything else like that. Okay, so it's just a tight cluster. It's not like a cell where there might be a membrane that is enclosing the nucleus. Okay, so it's just a tight cluster. So that's the proton. And then the second subatomic particle that we need to learn and understand just a little bit about to help us on our quest of understanding the atom is the electron. So the electron, which has an E, and then it does put its sign there. It's a little E negative as its symbol. And maybe that little negative will help you remember that it has a -1 charge. Now, one thing about charges, and I think I have it written on the next page, is opposites attract. So what it means is that the proton and the electron are attracted to each other. Now, electrons are teeny, 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 tiny. If I wrote their mass in grams, it would have a -28 grams. So they're much, much, much smaller than a proton. And if I put it into atomic mass units, you can see that it is 1/1836. It is negligible. The mass of an electron is negligible. It means we don't even know they're there based on their mass. I often say, if I went to the doctor and he said, you need to lose 5 pounds, and I said, well, I'll shave my legs and my head, and, I wouldn't lose, you couldn't even tell if I shaved my head, right, in terms of my mass. So that's kind of how electrons are. They don't contribute to the overall mass of that object. So compared to the electrons, the protons are like giants in terms of mass. So these electrons are found outside the nucleus. So if I was going to draw, I want to make them small. So there's 1, 2, 3, 4. They're out inside what we call orbitals. So they're outside the nucleus, around the nucleus. So they're somewhere outside of it. And what we call electron orbitals or electron clouds. It's almost all empty space. The electrons are so tiny, then they're moving around. That kind of what keeps the volume. But they are teeny, teeny, tiny. So electrons are found outside the nucleus. We could call that in their electron cloud. And we'll learn a little bit more about that at the end of this chapter. Now the third particle would be the neutrons, which are a symbol N, and maybe by their name you could see that a charge, they are neutral, so they have no charge, and they also have 1 atomic mass unit. So look, the protons and the neutrons, in terms of their mass, or how much matters there, they are the same. And then they're both found in the nucleus. So if I was going to add neutrons, they would be here in this tight cluster in the middle. So you have a nucleus that's a tight cluster in the middle, composed of protons, which are a positive charge, and neutrons, which are neutral. And then surrounding them are the electrons outside of the nucleus. There's space there. They're moving around outside of the nucleus. And in what we call an electron cloud. Now, the electrons are moving around. Remember, electrons are negative and protons are positive. So we have this attraction between the positive charges in the nucleus and the negative charges outside of the nucleus. So now we have kind of the idea of what an atom might look like. Now remember, all of the mass is in the nucleus, right? So inside the nucleus is where the mass is. So let's look and see a little bit more about these different things, these different subatomic particles. Okay, so if we look up here at the top, I said like charges repel and opposite charges attract, which I've already mentioned in the previous page, but here it is again, just to remind you, because it kind of lets us understand even a little bit in a very basic way why the electrons hang around. Why do they like the nucleus? Because they're opposite in charge. Now, when we're talking about the atom, there's something called the atomic number. And the atomic number, they give a symbol of a Z. And this is what's important about them, is it tells us the number of protons in an atom. Okay, now we don't have to memorize this number. Look at the next sentence. The atomic number is found on the periodic table. So if I can find an element on the periodic table, I can find its atomic number, and I know how many protons are in the atom. So I'm going to turn the page, and so here's the periodic table we've been working with, and let's look at carbon, and it's kind of hard to see on this particular picture, but if you have one at home, you can look at it. Right there, that whole number is called the atomic number. So if I'm looking at carbon, what it tells me is carbon has 6 protons. Now, how do I know that? Did I memorize it? No. I just look and see that carbon is element number 6. So it has 6 protons. I could do the same way down here. Look, here's calcium. Calcium has 20 protons. And our periodic table is ordered by the atomic numbers. So you see it starts at 1, and we just go all the way down, even to these ones way here at the bottom where you can't see. And I could be like, okay, mercury, how many protons does it have? Okay, that's its atomic number. So mercury has an atomic number of 80, so it has 80 protons. Okay, so the atomic number equals the number of protons, and it's not a memorizing thing. It's something that we can find on the periodic table. So I would like to add this, and I want you to think about this. I put little squigglies when I wrote the notes the original time. Since, if you notice, all the different elements have different numbers of protons, what I need you to understand is it's the number of protons that determines its identity. So carbon has 6 protons. No other element on the periodic table has 6 protons. In fact, if I go to 7, the one element next to carbon is nitrogen. It's no longer carbon. If you add an extra proton, now it's nitrogen. So the number of protons determines the identity of the atom. That's the important thing about protons. They help us with the identity. Now, if we have an atom, then another thing we can know, if we know its atomic number, is we can know the number of electrons. So look right here. For any atom, the number of protons equals the number of electrons. So for example, if calcium has 6 protons, I could tell you that it also would have 6 electrons. We also looked at calcium on the previous page, and it had 20 protons. And I know these because I've done them a lot, but you don't have to memorize them. Look at your periodic table. If I know if calcium has 20 protons, I would know it has 20 electrons. So the number of protons is equal to the number of electrons in an atom. Now you might say, well, why are the number of electrons important? Well, the number of electrons, this is going to help us understand the chemical reactions. Okay, so protons tell us what element it is. Electrons help us understand chemical reactions, or how it bonds and forms new things. Now we also have the third particle, which is the neutrons, right? So we have protons, electrons, and neutrons. Now the protons, we can find, that's the atomic number. We can find that on the periodic table. That tells us its identity. We know, if we know the number of protons, we also know the number of electrons, because for an atom they're equal. And electrons are going to help us understand chemical reactions on the chapter 3 and 4. And then we also have the number of protons. So how do we go about, neutrons. I apologize. How do we go about finding out about the number of neutrons? Well, that's by something called the mass number, which has a symbol. They just call it A. I don't know why. So the mass number, which they would call A, is equal to the atomic number of protons, which would be the atomic number Z, plus the number of neutrons. Now the number of neutrons right here. So mass number is the number of protons plus the number of neutrons. Now, I cannot determine the mass number from the periodic table. Okay, so this is not something that I am going to be able to just look up. This is something that usually in some way or another is given to me. Okay, a lot of times they'll either give me the mass number and ask for the number of neutrons, or they'll give me the neutrons and ask for the mass number. But this mass number cannot be found from the periodic table. Now it always has to be a whole number. Okay, it's all because you're adding the number of protons and the number of neutrons, and those aren't fractions or decimals. Those are whole numbers. And it's related to, but not the same as, something we call atomic weight. So let's look over on the periodic table, because I want you to understand what atomic weight is. So again, if I look, and it's very hard to see on this periodic table, but here, if I'm looking at nitrogen right here, so the N is the symbol and 7 is the atomic number, and then there's this other number right here. Now this is what we call the atomic weight, or the atomic mass, sometimes they call it. Either one, they use them interchangeably often. Okay, so it's a number that's on the periodic table. This is not the mass number. Okay, the mass number, and we'll do an example of a problem. The mass number is equal to the protons plus the neutrons. It's a whole number. Now later in the chapter we will see how these two things are related, the mass number and the atomic weight, but they are not the same thing. So for example, let's say that I had an atom, and that atom had 42 protons. It had 42 electrons. That would make sense, right? Because protons and electrons are equal. And it had 53 neutrons. Okay, so if I knew it had 42 protons, if you find element 42 on your periodic table, if you don't have one in front of you, get one out. This is molybdenum, or Mo. Okay, it has 42 electrons, and then it has 53 neutrons. So it has an atomic number, which equals 42. Its number of electrons, they tell us, is 43. And then if they want to know the mass number, I could calculate it, right? Because I could say 42 plus 53, which equals what? 95. Okay, so if I had an atom that had 24 protons, that would mean it also would have to have 24 electrons. And if this atom had 28 neutrons, notice they aren't always the same. The protons, electrons, and neutrons don't all have to be the same, just the protons and electrons. So its atomic number is equals 24. Its mass number equals a 24 plus 28. I'm not very good at adding when they're not, so that's what, 52, right? And so what element, if you want to know what element is, you have to look at the mass number. Atomic number tells us the element. So if I find element 24, I would have chromium, or Cr. Okay, so that's how it all kind of fits together. Protons and electrons are equal. The number of neutrons helps us figure out the mass number. So the mass number tells us how many protons and neutrons there are together. And it is related to the atomic weight found on the periodic table, but it is not the same thing. Mass number is just telling us how many protons and neutrons that an atom has.